Hello, my name is Salagre, and I welcome everyone to this introduction to substrate materials in Unreal Engine. Have you ever looked at a game or animation and wondered how do they make materials look so realistic? Substrate material is the answer. It's Unreal Engine's latest shading technology designed to help you create photorealistic surfaces with incredible detail. Whether you're creating games or animations or architecture visualizations, crafting realistic materials is essential to making your project stand out. And with Unreal Engine's substrate material system, you can achieve stunning results faster than ever before. A system designed to give artists like you an unparalleled control over material realism. Now, you may be asking why you should care about substrate materials. In traditional workflows, creating layered effects like wood with a glossy varnish, scuffed plastic, or scratch metal often required complex setups and tedious workarounds. Artists had to stack multiple shaders, carefully tweak blending parameters, and constantly adjust settings to achieve the desired look. Substrate materials revolutionize this process by allowing you to stack and blend material properties directly within a single shader. This approach is fast, intuitive, and eliminates the need for cumbersome setups. Whether you are working with reflective surfaces, layered paint, or detailed textures, the result looks incredible in any environment. Substrate materials save time, streamlines creativity, and open up new possibilities for achieving realistic, dynamic, and versatile material effects. At the end of this video, the learner will be able to set up Substrate and apply it effectively in their projects. Next, you'll understand their layered workflow and advantages over traditional materials. You will also create a polished wood material with detailed properties like surface imperfections, followed by crafting a realistic glass material using substrate slab. Let's get started and bring your materials to life with Substrate. This is the result we'll aim for today, a stunning, multi-layered material that responds beautifully to light, environment, and camera angles. And the best part, you will be able to recreate and customize this effect for your own projects. Before getting started, we need to enable Substrate in your project. Go to Edit, Project Settings, and search for Substrate. Under the Substrate section, enable Substrate. Bear in mind, Substrate is still an experimental feature. Follow the prompts and messages to restart the project. In the content browser, we will right-click and create a new material and name it to m_wood. Double-click to open it. The substrate material root node is similar to the legacy material where you can feed the substrate slab and also other substrate nodes. All substrate material graphs must be connected to the front material input on the material root node. By default, we have the substrate for material function connected to the front material input, which also has some PBR values, which we can use to create a material. But in this case, I will delete the substrate default node and add the substrate slab by right-clicking in the graph and searching for slab and connect it to the front material. The substrate slab is the first building block to create a substrate material. The slab contains some inputs that determine how light interacts with the material surface, as well as other inputs that help us understand how light is scattered or penetrates beneath the material surface. Now I'll be using some Megascan textures. Let's drag them in. These are some wooden textures which I have already downloaded. connect the diffuse to diffuse albedo. In the ORD map, we need the green channel as it contains the roughness map. To control it, we can use a lerp node. Connect it to its alpha. Also adding two constant ones. Setting the value to 0 and 1. Connected to the roughness map. Similarly, to control the normal intensity, we could use flatten normal. Adding a constant, giving it a default value of 0.25. And flipping the result with the help of 1 minus, connected to the flatness. The wood layer is complete. Let us organize it by pressing C on your keyboard and give it a name as wood layer. Now let's create a clear coat layer with some imperfections. To do that, let's add another slab. Click slab. In the meantime, I'll just connect it to the front material input so that we can see what is happening in the preview node. I'll also drag some textures. These are some scratches, smudges, which I have downloaded. Now for the color, we could use a constant 3 vector. Press 3 on your keyboard and left click. Connect it to the diffuse and keeping it a black color. For F0, which is basically the Fresnel value from the center, I could add a constant 1, keeping a value of 0.05. Now that's out of the way. We can do the similar thing which we did for roughness. We can copy and paste the same method which was used previously and connect it to the alpha map. Yes. Similarly, for the normal, to control its intensity, we could reuse the same nodes from the wooden layer. Select these nodes, copy and paste. Connect this to the normal map. We could also control the tiling of this texture. To do that, we can use texture coordinate. Multiply, pressing M on your keyboard and left clicking. And connect it to the UVs of this texture. Along with that, onto the normal map as well. To control the dialing, use constant, giving it a default value of 1. Now to achieve the subsurface scattering, we need to add the transmittance to MFP. Right click, search for transmittance. Connect the MFP to SSS MFP. Now the clear coat layer is also complete. So let us organize. Clear coat. Now to blend these two layers, there are multiple ways to do that. One of the easiest way would be using a substrate vertical layer. Then in this case, we want the clear coat to be the top and the wooden layer to be the bottom part. Connect the substrate vertical layer to the front material input. To control the top thickness, we could use a constant 1, giving it a value of 0.001. Let's save this and have a look into the viewport how our material looks like. Let's drag a material and assign it to the preview ball and have a look at it. So yeah, this is a substrate wooden material which we have created. To have more control, we could convert this into a material instance. Before doing that, let me just convert some constant to scalar parameters. For the clear coat in the roughness, I could convert this into roughness length. And the B1 converted to parameter to roughness max. Save this. Right click to the master material and convert it to material instance, giving it a name of mi underscore wood, assigning it to the preview wall. Let's have a look what we can achieve. So if I enable both these values and reduce the max value roughness, so we could see now we could get a polished looking material, wood. If you want a rougher one, you can increase the values. You can change these values to achieve whatever result you want. So if you want a polished looking wood, you could reduce the value over here. So yeah, so this is a substrate wood material. Now let's create the glass material. Right click, create a new material, call it m underscore glass. Also convert it to material instance and rename it to mi underscore glass. Double click to open the material. Now in the root node, We'll change the blend mode to translucent color transmittance and scroll down. We'll also change the lighting mode to surface forward shading. Along with that, we'll change the refraction method from none to index of refraction. As we can see on the root node, we have now the refraction method. Like previously, delete the default node and add the slab connected to the front material. For color, add the constant 3 vector. For roughness, we could use a texture which I have downloaded. Drag it into the material editor. This is nothing but a fingerprint smudge texture. To control this intensity, we could use lerp, connected to the alpha, and add two constants, setting its value to 0 and 1. Also converting these two constants to parameters, naming them to roughness, min, and roughness max, respectively, keeping the value to 0 and 1. And now for the subsurface scattering color, add constant 3 vector, convert it to a parameter, name it as color, and from this color, we'll add substrate transmittance to mean free path, connect the MFP to SSS MFP. The default color, keeping it as red, and also we need a scalar parameter for our index of refraction. So press S on your keyboard, left click, and rename it to IOR, assigning a default value of 1.3, connected to the refraction, and save it. Let's check this into our viewport. I'll connect the material instance to our glass. Double click on it. And this is a glass shader where we can control the index of refraction method. Similarly, we could control the roughness of this glass by increasing or decreasing the value. So what we could do is we could get a frosted glass somewhat like this with fingerprint smudges on it. Or you want a clean glass, you can go a cleaner glass, glossy, shiny glass. Similarly, we could also change the color. And you can create multiple variations of these materials. So yeah, this is how you can create glass shader inside Unreal Engine using the Substrate feature. Congratulations, you have successfully created and implemented Substrate Materials in Unreal Engine. Let's recap what we have covered today. We started by understanding the basics of substrate material. Then we created a realistic wood material with a layered varnish top. Finally, we created a glass material with some surface imperfections. What are the next steps? Experiment with creating other materials like metallic surfaces or fabric. Explore substrates' ability to handle dynamic materials for interactive environments. With these tools, you are ready to create more complex and visually stunning materials. Keep experimenting and push your creative boundaries. That's all from my side. Thank you.